This is the continuation of the previous video. So the version number of the software is 1.3.1. As you can see, the last digit is the revision number has been increased because I have made a small change to the screen layout. Otherwise, there is no functional difference between this software and the one we saw in the previous video. So I'm going to place a new tag. The tag I used in my previous video is already destroyed. So I'm going to connect and choose the Ultralight EV1. I would like to recap what we discussed in the last video. So before you read or write the tag, the first thing we have to do is to activate. So in the activation process, the tag ID is read and the tag is ready to accept the read and the write command. And we also seen in the last video the first 16 pages up to here, this is identical to the Ultralight, and the only difference between this and the Ultralight is the additional pages. So we have got 4 additional pages. The first 2 page, the page is for the configuration. We have got 2 pages for the configuration changes, and 1 for the password and 1 for the pack value. And we know that this tag has got 3 counters, which I have shown right underneath the last page. So keep in mind, in the last version, the last video, I had a number here starting from 20, 21, 22, and I thought that was a bit of a misleading, so I have removed those numbers, and this changes has made me give the revision number 1. So I'm going to explain the features or the working of this tag along with the documentation as well. So I would advise you to read the documentation, keep reading it until you know you are thorough in how this tag works. So the documentation says the unique 7-byte serial number is stored in the very first few pages. So as you can see here, the page 0, in the page 0, the first 3 digits or the first 3 numbers of the UID is stored, followed by the check byte, and the remaining 4 numbers of the serial number is stored in the page 2. And in the page 3, you have got the check byte for this 4, and this one is internal, means it is not used, it is used by the system, or it's not available for us. And in the page 2, the last 2 bytes has got the log bytes. So there's also some information about how the check byte is computed. So for example, this check byte is the XOR operation of the SN0. See, this is called SN0, SN1, SN2, and also the CT stands for the cascade tag, which is the number 88, hex 88. So likewise, there is some information about how to interpret the serial number and this the BCC. So we know that this is the 7-byte UID of this tag, and if you compare this UID here, so the first 3 bytes, the B0, B1, B2 corresponds to the first 3, and this EC is the BCC. So next is the remaining 4 bytes of the UID is stored in the second page, and the checksum of this or the BCC of this is stored here. So you can compare or compute the BCC by XORing all the 4 bytes, which I have shown in my videos related to the UID changeable tags. And this one, it's, as we know, it's an internal thing, and these 2 bytes, that is a byte 2 and byte 3 of page 2, is for the static locking. So the next in the documentation is about, we saw this is how the static lock bytes are stored, and there are 16 bits, and each bit locks a single page. For example, this is called as a lock byte 0, and this is called lock byte 1. And in the lock byte 0, the first bit controls the page 11, the locking of the page 7, sorry, it's page 7. Next is page 6, page 5, and so on. And likewise, you got up to the lock page 8. So if you go back to this software, and if you look at the locks tab, now the static lock I have shown in a grid here, and is exactly the mapping of the document. You got P7. So I am showing here as a page 7 locking. So I'm not going to do any locking at this time. I'm going to eventually lock all the pages, and eventually by the time we finish this video, we are going to destroy this tag, make this tag probably unusable. So usually most people, what we end up doing is we try to write something and read it. I'm going to show you how to do that. So I'm going to write some text. I'm going to go some text from page number 4 to page number 15. So this is the tab, you can type in any text you want. So this is Ultralight EV1 tag. This has password protection, and you have to keep in mind, even though you got such a big space here, you cannot put more than 64 bytes, I suppose. So you got right from page number 4 to page 15. So I'm going to first transfer this text into this grid. So I'm going to do this from page number 4 onwards. So keep in mind, the page number 4 onwards is called a user data up to page number 15. So every page, they got some predefined functions. So you cannot store the data into the configuration or a password or a counters. So I'm going to transfer that here. So looks like all these values are changed. Probably it's also worth noting that when you buy a new tag, the memory content of all these user data was 0. So if I go to ASCII mode, you can see what you have written here. So you can see something has been chopped after this the PROT. Probably this is what the 64 or 64, you have to count here bytes are. So once we do that, we have to write. So if I hit write, you got something called string right here. We still don't know. It should have written. I'm going to close. I'm going to take out this tag and place it back. I'm going to activate. I'm going to read the tag, and you can see that the data is indeed copied to the tag. So if you want to change the individual pages, you can go to this user data tab, and as soon as you click here, the text box are populated with the 4 bytes here. So you can see if you click on text, you see the text equivalent of these bytes. So you can type, probably I'm going to change this text as, say, ULEV. And when you hit this write, we are physically going to write to the tag. So if I say write, now the page 4 has been written okay, and you can do the same thing, take it out if you want to check, reactivate, So you can use this word reactivating the tag, reactivate and read. So you can see that it's written here. So likewise, if you want to write to more than one pages, you can use this section here. So I'm going to reset the tag back to 0. I think you have to put 2 zeros here. So I'm going to copy this 000 from page number 4 to 15. So right, and as you can see now everything has been written. So you can check it. Okay, now I'm going to show you quickly now how do you work with more than one tag. So you don't have to close this screen and restart the software. You just take out the tag and place a new one, and click on activate. So you can see that the number has changed. However, I'm not cleaning any of this grid. Probably I'll do that in the next version. So I'm going to reactivate the tag we are using, and we got no data here. So next I'm going to show you how to password protect. Everything in this tag is same as Ultralight. Probably you have already seen my videos or played with an Ultralight tag. So I'm going to show you this password protection now. So before you do the password protect, the first thing we want to do is we would like to put some valid data. So we already had some data, like this is Ultralight. This is a very quick way to transfer the data into the tag rather than going here and doing page at a time. This is Ultralight EV1 and password protected. So I'm going to copy and I want to write. So write is successful. I'm happy with that. So how do we change the password? So a couple of things about this password protection. Now when you buy a new tag, the password is changeable, and the default password of a new tag is all FFs. So remember, password is a 32-bit number. Actually it's a 32-bit number. You can just put in whatever password you can remember, but keep in mind you have to remember the password, otherwise you cannot identify the password. So you can probably you can put a loop through and go from 1 to some billions and find out, but that's not we are going to learn here. So I've written something. I want to change the password. So I want to change the password, something I remember. You can keep the password in your database along with this UID, and it all depends on how you design your system. I would like my password to be so that I remember A, B, C, D, E, F, 0, 0, or probably I'll start with the 8, 9. So I got all. So these are in hexadecimal number. 8, 9, A, B, C, D, F. Okay. First I'm going to write it. So I've written the password. You can see the password here. However, I'm showing because we just wrote the password and I'm just copying this number here. And look at the way the password is stored. See, we typed here from the most significant byte to the least significant byte here, but actually it's stored as the byte B0 has got your lower byte, B1 has got your second byte, and B2 has got your the third byte, and 8, 9 has got your higher byte. Now if I take out this and try again, see what's going to happen when you try to read the tag. So in fact the software is reading the content of page 18 but nothing is returned. You get the default 0 values. If you look into the documentation, it's mentioned somewhere. If you go to search for a pack or a password, or the best thing is, look for remarks. All the things you're supposed to know is mentioned. All the things that needs a special care are put under remarks. Yeah, look at that. It says when you try to read, all 0 bytes are applied to the PCD. The PCD here is the reader writer. So search for remark. I think you should search for remark in all these documents, so that these are the things we need to consider or give some special care. Now at the same time, and also for a new tag, anybody can change the password, anybody can change the pack, because it's not protected yet. So I'm going to also change the pack value as, I'm going to choose decimal, say 100, write it, so the pack value is written as well. Remember, even the pack cannot be read, so I'm going to reactivate this tag again. So read, so you cannot read the pack and the password. Now how do you get this pack value? So for that you have to authenticate. So I know the password as 89ABCDEF, and when you authenticate, you will get back the pack value. Authenticate, and you can see that the pack was 64, which is in hexadecimal. You get this 100. Now you learned how to change the password and how to change the pack. So keep it any time you can go and change the password. So I'm going to change my password as, you don't have to authenticate in order to change the password. So password changing is open to everyone for a new tag which is not configured yet. So we're going to see the next thing, how to configure. So I'm going to make the password as say 8989, all 8 nines, right? And pack value, probably I'll set it to 10. Okay, so we know how to change the password and the pack value, and we also know how to authenticate. Now what is going to happen if I type a wrong password? So I'm going to authenticate with the password 8 instead of 9. Let's see what's going to happen. Now the authentication failed, and also let's try to read the tag and see whether the tag responds when the authentication fails. So when you try to read, the read fails as well. So the tag has stopped responding to all our commands, and there's a reason for that. To understand that, you have to go and look at this the block diagram. See, in this block diagram, I'm going to okay, if you look at the block diagram here, so this is how the card is activated. I've made a video using CR95HF. I've explained every step of these states, so please see that video. Now initially, all tags, when I place it on this reader, the ideal state, now you go through this activation process with anti-collision 1, anti-collision 2, and activate in the active mode. After the password is authenticated, so it will be in authenticated state. But look at the remarks again. See, the command interpreter returns to idle state on receipt of an unexpected command. It's exactly what we did. So we try to authenticate with the wrong password, it will go back to the idle state over here. So the only way to come out of this is a proper authentication. So whenever you come across these type of error messages, you have to activate again. Just go and hit activate. Now we know that the message is gone, so the tag is activated, and you can read. So what we have done is, it's alright, but what is the use of changing the password when everybody changes the password? Everybody can change the password. So if you give this to a customer, the customer can change the password and put whatever password you want. So what we're going to do next is, I'm going to tell the system, in order to modify any of the user data from here to here, user must authenticate, must enter the password. So we're going to do that using these configuration pages. Now there are two configuration page, config 0 and config 1, and the documentation explains what this where to find what, how to convert this into the bytes. So if you look at what we're interested here is, I would like from page number 4 onwards, so nobody can, I want to, sorry, page 4 onwards, I want everything to be password protected, but only for writing. So first thing we do is, we are going to set from page number 4. So before, I think the order in which you do this is, first you have to set this config 1. So it is already set to right. This is the default value. So I want the password to be, I want the page number 4 onwards to be password protected. So right, I'm going to give right. And my software is showing you that, from page number 4 onwards and up to here. In fact, this is a bit wrong here. Probably I have to clean this up. So the reason I have to clean this up is, if you see the documentation, counter 0, counter 1, counter 2, they're always open for reading and incrementing. So you cannot control the counters. So that will be gone in the next release. So what we have just done is, whoever or anybody wants to write to page number 4 onwards, you need to authenticate. Let us give a try. Now the software, at present, it tries to block doing that. For example, if I go here and say I want to modify this with the text, say ABCD, right? Now this is the message given by the software, not by the tag. It says write to a protected page, authentication required. So we can't do that here, but no, you just can't write it. I'm sure you will get error message. So in order to write, you have to authenticate. So first thing I'm going to do is authenticate with the authenticate, and I'm going to write. So probably in the later part of the video, I'm going to show you, I'm going to prevent these messages, and we're going to say what exactly happens when you try to write to a protected page. So I'm going to write with the THAT. I'm just going to modify the last 2 characters, right? So write is successful. Now, so this is how we protect from writing. What about from reading itself? So I don't want anybody to read from page number 4 onwards until unless it is authenticated. So I'm going to change this, the prot value from 0 to 1, which is read and write it. Now, so what we've done is, everything from page number 4 has been protected. So I'm going to close. I'm going to reactivate, activate. I'm going to read. As you can see here, the read operation failed after page number, from the page number 4 onwards. It is because we have set this configuration so that from page number 4 everything has been password protected. Now how do you do that? So now the tag has gone back to the ideal state. If you just remember what I mentioned 5 minutes ago, there was an error, so I have to reactivate. Now I'm going to authenticate. I know the password is 898989. I'm going to authenticate. Authent successful. Now I can hit the read button to read this entire tag content. So that's it. I can also make this authentication required from the page number 0 itself. Let's write this thing. Now what we have done is even the page 0 can't be read. Now give a try. Activate. If you try to hit, look at that. So now this tag is completely protected from reading and writing. So this is a nice feature to have if you are doing a project that uses the Ultralight EV1 tag. So nobody can see what's in the tag. Now in order to come out of this, you have to activate, then go to the password section, type authenticate. We got back the pack as well. Now this is what the software does. Because you know the password, so I'm showing the password in page 1819. Now I can hit the read. Now all the read operations done now. So other than that, the other simple things are, I mentioned this in my previous video also, the get version. Now this is one of the important, it's for us, it's as a developer, it's very important feature, because I can, or we can use this information to identify this is an Ultralight EV1 tag, not an Ultralight tag. So you can use this command to differentiate between Ultralight E and Ultralight EV1. And I can also use this ECC, and you can you can store this in your database along with the UID, and probably you can use this to identify your tag, or probably you can use this to create some kind of a hash or a encrypted. And so this is really useful if you want to make a secure tag. So I'm going to show you how to remove this password protection now. Now we are authenticated, because if you look at this the page number, the password and the configuration are in page number 16 and 17, and we have protected anything from page number 0 onwards. So if you want to modify this page, configuration page, you must authenticate first. So I'm going to change this the password protection required to page number 16 onwards. Let's see what this configuration does. So what we've done is, anybody can read up to page of 15, but in order to read or write from configuration page onwards, you have to have a password. Now I'm going to take this tag out and reactivate. So look at that, you can read up to 15, because this program goes in a loop reading from page number 0 to page number up to 18 or 19. It throws an error soon after the 15th page. So to overcome that, you have to activate, and you have to enter the password, authenticate, then read. Now we're able to read. If you want to remove this authentication altogether, set this to any number higher than the highest number here. The highest page number is 19. If I put the page number 20 here, now this removes the password protection for the entire tag. So I'm just going to activate again. So look at that, I have not authenticated, but I can go and change my password. I'm going to set the password to, this time I'm going to change it to 778899EAA. Right? So look at that, I can write the password. So password can be returned if it is not protected. So the next thing you need to understand is about the auth limb. Probably the auth limb, probably we can do that later stage. So what about this VCT ID? Remember I mentioned in video 1 that this is a very it's a feature, it's a good feature for a software developer. So I have used this in one of my project to identify the type of the tag. Say for example, we can use this, for example, 0. So I can set this as tag VCT ID as a 0, and if a tag has the value of 0, I can identify that as a, for example, a visitor card. I can set this to 1. If our system reads the value of VCT ID as 1, so our system can treat that tag as a employee tag. If it is 2, we can have a system treat these tags as a manager's tag. So like that, using this depends on our system design. But whatever you write here, there has to be a command to read it. So there is a special command. Remember, these values are part of the configuration. Now I'm going to this is a part of configuration. Okay, it's stored in configuration 1. So if you are able to read this configuration 1, then you can obviously read the value of VCT ID. What if the configuration is protected altogether? So let's give a try. I'm going to protect this everything from read and write from page 0. So let's go and reactivate. Oh, so read fades, we know that. So reactivate again. Okay, now I can't read it. So without knowing the password, is it possible to identify the type of this tag? So in a typical system design, probably the first step is to identify the VCT ID. So then if VCT ID is equal to 0, we use this password 1. If it is 1, we can use a different password. If it's a 2, we can use a different password. So depending on the type of the value of the VCT ID, we can decide what kind of password to be used. It's a very nice feature. Now because we cannot read any of the pages, we are going to use this special command called the VCSL command. I think the virtual card select, I suppose. Now this command it's pretty different here. So if you read the documentation, you'll come to know you have to have some 14 bytes values followed by that. I've never understood the meaning of these things. I just follow the documentation, and if I read, look at that, you can read, you can get the value of the VCT ID. Based on this value I can authenticate with a different password. It's a very a nice feature for software developers. Hope I remember this password. It was sorry, just forgot the password. So I just had to rewind the video and find out what the password is. 99EAA, authenticate and read the tag. Okay, so that's a nice feature. The other thing is, as I mentioned before, there's one more feature called the strong modulation enabled. The default is the disabled, but you can set this to enabled, and it just write the value to conversion 0. I'm not sure. I think there's something to do with the antenna probably, or there's a modulated signal going on between the tag and the PCD, something to do with this probably, because I don't know that, sorry. The next thing we can do is the configuration lock. So assume that we want to lock this configuration altogether. So this is what we do as a software developer. So once we set the configuration, see here, this log bit logs only this config 0, config 1. It doesn't log any of the pages. It doesn't log password or pack. Now probably we have decided the value of this authentication. Assume that I want to have authentication from 4 onwards, and I have written something to config 0, and we also want the auth lim. So I'm going to set the auth lim to 3. So probably I have to mention something more about auth lim, so I'm not going to lock at this stage. We're not going to do lock now. Okay, now let's see about this auth lim. See, this auth lim controls how many times the system, the tag, allows the wrong password. Now if I set the value of this auth lim to 3, so we are allowed to do have the wrong password 3 times. The 4th time you do the wrong password, the system, the whole tag is locked, and the lock depends on what kind of the protection we are. For example, if it is write, assume that the tag was set to write and we entered the wrong password 4 times, you cannot write from that point onwards, even though you remember the correct password. I'm going to show this, and that will be the end of the video, because after that this tag will become unusable. So I'm going to probably with this background information I'm going to lock it. So we have decided we want that to be write. We want to only the write is protected, and protected from page 4 onwards. We have done this right, and I'm going to write, protect the write operation from page 4, and I'm going to have the auth lim of 3, and probably now we have decided to have this as 75. So you can change whatever you want, and you're going to do this for the last time, and after that I'm going to say lock it. Say write. Now as you can see here, I'm showing here as a locked column S, and this is locked completely, so you cannot change the configuration from this point onwards. I can read without authentication, so it's no problem here. However, in order to write it, so let's try to change. If you go to the configuration here, so the software doesn't let you change it, because this is disabled by the software, and probably now I'm going to introduce a new feature here where you can let user to do that. So this is how you learn, by trying out yourself. So let's try destroying this. For example, if I want to write, I have to authenticate. So let's put my password 778899AA, authenticate. I'm going to write now. Say write, I'm going to write in page number 4. Just put some number there. So I'm going to say 45,900, or you can put, you can put 32-bit number. You can go up to any number here. Oh sorry, it's too large, it can't be that much. Some number, I'm going to write it. So write is successful. We just wrote here successful here. Now I'm going to authenticate with the wrong password 3 times. So let's try to do that. Assume that some user trying to read our tag, and probably he's trying to guess, okay, guess what's the password. So we are going to try with the 99 and EAA. So I'm going to type this time EA0. Authenticate. So we have got one wrong password. Try the second time. Activate. I'm going to try something different altogether. Authenticate. We did second time with the wrong password. So keep in mind, if I try with the right password here, say A with 778899EA, the auth lim or the wrong password count. So keep in mind the tag maintains the number of consecutive wrong passwords. So assume that you had a wrong password. You had a wrong password for the first time, second time wrong password, the third time if the password is right, the counter, the internal counter set back to 0. So that's how it works. So in order to lock it, you must have all the 4 attempts with the wrong password. Now I'm going to try with the third time. I'm going to try authentication. It's failed. So it's not possible. No, I have to reactivate. Sorry. Read the tag. You're able to read it. Go with the password. Wrong password. Authenticate. Password. Authenticate. I just forgot how many times I did, but let us try to put in the right number, right password, and see if I can write it. So, or if you can try authenticate. So I'm going to authenticate with the 778899A. This was our password. Give authentication. Look at the authentication failed. So even though you put the right password, it fails. So what do? You just cannot authenticate this tag anymore. So this tag is gone forever, in the sense, and you cannot ever write. So this is completely locked. However, you can still read and write. I can still read it, but you cannot change. So we just destroyed this tag. All other stuff, say for example, I can still do this OTP. I can still change the locks. Say I'm just going to destroy this further. So let's go and write some OTP bytes. This is ticketing. This is good for ticketing applications. I can just give you a small example here. So assume that we are using this tag for a 25, or for example a 10 visit card. I want to make this a 10 visit card. So during the personalization, I'm going to keep only 10 empty slots. So I'm going to write all these OTP bits and just keep 10. Right now OTP is write successful. Now what we have just done is we have created a ticket which can be used only 10 times, and we are going to use only this OTP. So assume that today was the first visit. We are going to put a tick and write it. So we have got only 9 slots left. So likewise, the static lock, it's very straightforward. So I could have completely locked the pages. So because this tag is already locked in a different way because we missed the password. So assume that I want to lock the page 7 and page 6, right? Okay. Now I have spent I've got so many videos explaining this static locking. Please have a look at those videos. And I also explained what this the block lock is. And block lock, as the name says, block the locking. So if I put a tick here, I cannot change the lock of page number 15 to page number 10. So for example, if I take this and say right, now what it means, this is the way, this is the bits you're going to lock, you're going to use to lock the pages, but because of this tick here, it's going to prevent. you can't lock anymore. So assume that what I also want to do is from 94, so this bit here controls the block locking from 94. I'm going to, before somebody do that, I'm going to say 4 is locked. I want to keep 5 open and 6 and this, and probably 9 is locked. So I'm going to freeze the lock status here. I'm going to say this. Now what you have just done is I cannot change this any further. I cannot change any of the bits corresponding to page 4 and page 9. I can't change because of this bit. I think so that's all about Ultralight EV1. The next video I'm going to show you, I'm going to explain all these various commands and how ACR122 communicates with this EV1 and what are the different commands we have to understand from the documentation.